to present Novapoint 19 DCM, Merete Tundel and Heidi Berry from Vianova Systems.
Vianova Systems proudly present Novapoint 19 DCM, the first step into a true infrastructure BIM system. What's on today? First, we will guide you through how we see the industry. Then we follow up with the products. We continue with benefit and business, how we see it. And in the end, what's in it for the end user, you. We are a total provider of infra solution. So that's the focus to continue with. So how do we see the industry? We see a shift in the industry, and we find it very exciting. We have gone from drawings to a BIM life cycle approach. We have seen in the Nordics for a while now that we use BIM models, but the list is not long. It's a list of pioneers. Some of them are sitting here today. Focus has been on 3D, but in a few cases also cost and time. Trends now is that the clients start to ask for more models in a life cycle perspective. They want more information at object level. So, changes in the client procurement. It's also very interesting to see that the client asks for models. More projects are now mainly delivered by modules. This implies an increase in the needs to support the BIM models. We have to find out who have done what, when, for example. We also see that we can, now in the future, think that open formats will be required from the clients. For some domains, we already see it. Collaboration between stakeholders. Collaboration between stakeholders we think that is a key factor now to have a shift in the industry. And we have seen now that we have it between domains, we have it between phases, and we have it even between stakeholders in the life cycle. We even see it between RAID and role administration, and we find it very interesting. So, a little bit about communication. The information society is something that we have to take part of as well. The requirement for the public, the information, is increasing. We have seen great results using 3D model as communication between stakeholders in the early design. But still most of the projects are delivered traditionally. There's a great potential, in fact. How can we make all projects model-based from the beginning? We have a phrase. One drawing says more than 1,000 words, and one model says more than 1,000 drawings. So, productivity increase. This is the industry. This is not good enough. We have to do something. we think that processes and tools will be much more important now in the future, and we have to take a change here. We are pioneering the industry. We have now a framework for the building information model for infrastructure. And we also have business information management, where we can support how we can, for example, have project management in the future. So, to the product. What are we presenting today? What's inside it? We have been focusing on 4 main areas. It's a map, and it's terrain, it's design, and it's information in one common model. So, if we first take the map and the GIS information, we can, for example, handle area information. If we continue with the terrain model can have a much more detailed information about, e.g., the existing situation under and over the ground. Then we have design information, and we have information around that. And we have roads and structure with a level of detail that is ready for construction with a very good quality. So, in the end, we now have support for an integrated process model inside the solution. We can take care of a plan, we can plan and we can maintain, and we can quality assure the work processes. We think that that is maybe the most unique with our solution. So, over to the product. We will guide you through the essential part of the product.
With the Novapoint 19, we have moved the work tasks into the common information model. That's quite a big change, it's a big step. Like this example from E16 in Sandvika, which has been worked on for a while, we can see that the task model up to the left actually has documented every change done to the model and how each object were created. Like this road, for instance, how was it calculated or imported? When you start a new project, you will typically select from some templates. Here we select a standard of the process code in Norway, and then it establishes the task tree for you, which will, after that, record all you do with the model. A big new thing is handling the CRS through the whole system, from beginning to end. You typically start up with one of the templates we have in the system. We support all the UTM, the NTM, the SVRF, etc. So you set the CRS for the system. And you could always, when you enter a model, you could always go in the general property view and see what CRS is active in your model. We also have a validation during import of a file. Is the file the same CRS as the model or not? If it's not, select from a transformation library. Existing infrastructure. We get a lot of our information in the beginning from maps today. Like here we have imported a map with some buildings, but we want the buildings to be raised to 3D. So I select a set of buildings, and I select to which level or which surface I want them to be extruded. And then the system calculates a volume for all the selected trees, houses. And because of the quality of the map file, you see that it's quite a good recognition of where you are. So it's a good start when you start designing in a city, for instance. It's only based on map data. You always get a lot of existing infrastructure as only lines or points. Here we want to extrude a cable pipe around a cable that is only a line. So I select a set of cables from my integrated 3D view. I then see that they get selected. They're red, so I know I have the correct objects. Then I select a shape for the extrude, if I want it circular, square, what dimension, diameter, and so on. And the volume is then calculated and extruded and stored to the model for all these cables. Here I selected some cables, but I could have selected the object cable for the whole model and then run extrude just once as one task for the whole model. Another example of using this could be that you maybe get design data from someone else only as lines, and you also want them as volumes. Here we have a set of safety barriers, which came in with an import from a DVG. So now I use a selection based on the task, the import task. So when I select that, I will see that the safety barriers are marked red in the model. Okay, it's the correct objects. Once again, I select the shape for the extrude, the dimension, if I want it to be massive or as a pipe or a hole. And then the volume is created and stored to the model. And of course, it gives a better view of the end result. Another typical situation is that you will have a lot of 2D information, 2D points, and you want them to get a set value. Here we have a set of trees that I know that should be kept through the whole construction phase, so I want them to be visible in my information model. Then I select the actual trees using the task selection again, and I tell the system when I've selected all the trees, you see them get marked red, you're in control. You say to which surface or to which level I want to raise these, and I select the top terrain surface, it's natural. And with an offset of 0, the trees are actually then moved up to the terrain top surface, so they get a set value. And you can always go and control this afterwards in the integrated 3D window. And it seems like they ended up where they're supposed to. We have multiple ways of adding terrain to the model. But here we have imported a land XML TIN file, but with land cover use. So when you click on the different areas in the cross-section window, you see that they get selected also in the other dynamic views. And all the information about the area is in the property view. So they all came in, all the information came in during import and was stored to the object. And together with the 3D buildings and then the terrain with the area information, it's a good recognition, it's a good start to go on for your further design. Novapoint land use planning now store data directly to the information model. That means that the land use information is available for all other domains, all other users of the information model through the whole project. And they could always go and click on an area and get all the information about the land use up in the general property window. To summarize all this GIS, all these tools to enrich existing infrastructure model gives a head start for the designer to go on with his further design. Like this example from E16 Sandvika, where the road designer has just started on his actual road design. A typical object that changes a lot in the beginning is the alignments. So you could always click on an alignment and get all the geometric information. All the parameters are available inside the property view. If you want to go and make changes to the geometry of the alignment, you do that in the same windows as earlier, same dialogues. You enter new parameters and the preview do the changes so you see how the alignment becomes. The big difference is maybe that the calculated line is instantly stored and shown in all the dynamic views inside Novapoint. So now the alignment is a bit underneath the road. So I want to go and recalculate the road model. The recalculation then removes the former stored road and instantly store automatic the new calculated road to the model, so that you see it updated at once. So then it's easy to go and look at some different domains like bridge, piles, etc. in the area to see if there are any conflict or if the bridge and the road fits well together. You also see the section numbering in the 3D window that gives you an overview of where you are. Then to the Quadri Cloud. Now you are in charge of your model data. You can share them with any other user of the information model at any time. And you could download all the other ones' data. Here, my colleague in Belgium is doing some changes on his railway. He wants to share that with me, so he hit the share button on the Quadri Cloud. He writes a small description of what changes, which object he has done some changes on. That is practical because you also have a button in the Quadri Cloud that says, what's new? So every one of you could click the what's new button during your day and see if some of your colleagues have done changes to the model that you need for your further calculation. So then you will get a list of all the changes. And you can choose to download if it's necessary for you, or you could wait till there are updates that you are dependent on. Now I log into the server back home, the same model server. I choose the same project, and I choose to download the whole project from Quadri Cloud. And I will see then that I get the exact same model as he has. I could have selected only some of the objects if I just needed some of them, but now I took all of it. And here we see the same task model as he had up to the left. And this is maybe one of the biggest benefits with the task model, because it gives a great overview of what all of your other colleagues have done of changes to the common information model, because it documents every change. So it's a good way of follow up the project, the common project. If I want to do changes here, I can do changes, hit the share button, and then it's updated for my colleague in Belgium. It's important to be able to get information into the model. You create objects and you add intelligence on the way in. Like this manhole imported from the Novapoint Water and Sewer Library is now divided into different objects. The dividing them into objects is done during the conversion of the file when you import it. Here is a conversion file based on import from DVG. So I have mapped from a layer name in DVG until a given object inside Novapoint. But you could actually also map from a given layer name till the object manhole with the property value concrete on material. So it's not just to an object, but to an object with more information. And then it's data out from the system. You could, of course, always draw all your views in the model to AutoCAD. For instance, with standard map drawing rules, as you used to today. You can select from the different windows you have defined inside the model from the standard Novapoint menu. You could also easily isolate which objects you want to have in one separate drawing. So you don't have to remember which file object came from. You just select objects, like here, fundaments, from a model, from the general model, and export it to DVG. So when you are selecting objects, you could also always have these dynamic views open, like here, the long section window. You could either select to have a long section along a given line, or you can draw a line for the long section. It's always shown in the plan view where your section is. And you could choose to show all of it, like here, or go into the selection dialog and choose, I only want to see this object and this object. You see also here that it gets marked red when I select each new object. And this long section cuts through volume objects, surfaces, lines, so you will have everything in your long section. And then finally you choose a drawing rule, which also will be the drawing rule for the DVG, if you draw it to AutoCAD. Once again, when you select an object in one dynamic window, it's selected in all the other windows, so you're in full control of the model. Draw it to AutoCAD in plan or in 3D, or you could, of course, also keep it in the model longer because you have a good overview of your project, both in 3D and cross-section.
So, to the benefits. What benefits do we have using this infrastructure information model? What's in it for the planner? We have improved communication with stakeholders, because we communicate through models. On the other hand, we also have a shorter decision making because everybody understands what they decide. And for the designer, we have better communication between different domains. We have access to information and design data at object level. And we have also the possibility to support the work processes for the different companies. And the contractor, he has always real-time access to the design data. And they are ready to construct with a rich quality. He has access to the virtual model anytime, anywhere. And we hoped that less conflicts between the different domains will help to be more efficient planning the construction's daily operation. So the client, he have a real-time overview of the project, and we have also now a support for how we can handle new procurement. So benefits for the society. We say that we can improve the democracy because we have a better decision making. And we have seen now great result using 3D models in early design planning. So we know then that the politicians dare to risk and take a decision because they know what they say yes to. This will speed up the planning process. Is it something in it? Talking about money. Yeah, we say that we have the possibility to save billions. The goal is more infrastructure for the money. That's the goal for all of us. We have now a case study in Norway. We had there a result. It was a project north of Oslo, and we had pilots there, and we will now tell you a story about how we can save 4.6% in construction costs. It was one and traditional enterprise. It was totally 250 conflicts out of total 600 changes that was caused because of conflicts between domains. In average, we say that this cost 55,000 Norwegian crowns. That's numbers from the Norwegian Road Administration. And then we know that this 250 multiplied with this amount says that this was a cost for the society of more than 13 million Norwegian crowns. Then we follow up with a new case study where we ordered a collaboration model. And the changes caused by conflicts between domains was almost zero, almost zero. So then, it was Veidekke, a big contractor in the Nordic, who said the following about the project. The 3D models we get for all domains makes our working day easier and more efficient. There has been almost no design change/conflicts on this parcel. We follow up with another case story, and here is from Skanska, also a Nordic major player. Because of less conflicts between domains, it helped us to follow the plan for operation, and therefore got less stop in machinery and equipment, which increased our efficiency and productivity, and gave a better economy in the project. So, we have already, in this case, the possibility to increase the efficiency, productivity, and innovation, and the challenges we have in the industry.
Over to technology. We have 3 major new technology parts in our system. The quadri-cloud that makes everyone able to share their own model data with all the others. You don't deliver them to one person who's supposed to put them together. You deliver your data to the quadri-cloud, and you update and get the data from the others. So how do we make this work? We are implementing read and write access, login, model check for model changes, how to divide objects, and also the verification, and to reserve objects, to say that I am going to work on this object now, so no one else can do changes on it. It's a lot of technology involved to make this work. So the full integration on QuadriCloud will be available in near future. The next big thing is the network. A network technology, which we here can see, it's actually the main road network for the whole Norway. So it's inside Novapoint 19. With a network technology, you get the infrastructure model to be linked together in a system. And that is an efficient way to search along a network. So one example could be that since we have the network, we could run analyses like how many manholes are there along all the roads in this municipality. So because of the road network, we have those possibilities. So it's a powerful part of the system. The third big component is, of course, the object model, based on an ISO standard. And today, how it is at the moment, it's 1,150 objects inside this model. These objects were defined looking at and harmonizing towards map objects, water and sewer map objects under a new standard there, city GML, and also land use and land cover from the INSPIRE directive, European. And of course, we have created a lot of new objects where we couldn't find objects in any existing standards. But we think that, and we really believe that this model is so open and flexible that it will be easy to extend it with new objects that will be necessary in the future. So what does it mean to be based on the ISO standard TC211? It means that you get some guidelines for how you build up, for instance, a feature catalog, how you position your objects, how to handle time. And it also means that the model is GML compatible. So data modeled in Novapoint 19 could be exchanged with other systems that are based on the same standard, for instance, using GML as a model exchange format.
So the most important, the end users. It's all about human. Can we together move the industry? We have said that it's 20% technology and 80% human. I don't know what the future is about, but maybe it's 30-70, I don't know. But the most important thing is that we can't change the industry before the designer have all their domains inside the model, and before we have project managers who dare to take the risk and go into this model. So we think it's very important that everybody understand that they have to take the step. So how can we move? What's in it for us? We have a true model which says that what you see is what I get. The model is in your hand. You are the one who have the knowledge about your domain. Keep it. Don't deliver it to the 3D apartment. We don't believe in that. We think that you are the one who know what to do, and you have to follow the project to the end. Your data is more important than ever. We create object once, and it will live for a whole life cycle. That is really fantastic. So, in the end, I think that, or we think that, don't use time on administration and files. Use your creativity and innovation, because that is needed in our industry. BIM for infrastructure is for you now, for everybody, not some special persons. So if we summarize the industry, we see a big change, and the industry need an infrastructure information model. We have heard about essential thing in the products, work processes, coordinate reference system, how we can take care of existing information, infrastructure with detailed information, collaboration between domains, access to the cloud, anytime, anywhere, and interoperability. Benefits is that we create the object once in a life cycle approach. Collaboration and transparency save billions. The new constructions within rail and road in the Nordic in 2011, unofficial numbers, was 7 billion euro. We can save the society for 280 million euro, thinking about the 4% that we can save at construction. So to the technology. It's access for everyone, anywhere, to the infrastructure information model. And the end user again. What you see is what I get direct from the model. So now, please download the beauty. It's all yours.
In Norwegian from today and international with server complete in February.
Thank you for the attention.